Okay, we have example 6.1, and this is a great example why you don't ever want to use this process if you can avoid it. We are trying to use the method of joints, using the method of joints, to determine the force in each member of the truss. Okay, why do we not want to use this process? Basically, if you have to figure out the forces in each member, there's no easy way. It's just going to be a bummer of a way. But we're going to show from this process that there's a lot of steps involved with this relatively simple problem. Okay, so what are we going to do? Well, we're going to start. The first thing you're going to always do when you start with these things is you need to get rid of these things here and here. It's not okay to have these big unknowns floating around there. So we have to solve for the unknowns here. So let's just do, this is a chapter 4 problem, right? Let's do the sum of the moments at C. Okay, so if we do the sum of the moments at C is equal to 0, you have 2,000 times, what is it, 24, plus 1,000 times 12, and that's going to equal EY times 6. So that gives you that EY is equal to 10,000. So there's a force here, draw it in here, of 10,000. Okay, now we have, remember, a force here and a force here. So if we do the sum of the forces in x equals 0, that's going to tell us that Cx is equal to 0. That was pretty unexciting and kind of expected. And then we're going to say sum of the forces in y is equal to 0. So the way we drew this, you have Cy plus 2,000 plus 1,000 is equal to 10,000. So Cy is equal to 7,000. So we drew it in the right directions down like that. So this is 7,000. Okay, so that's the chapter 4 stuff. So now we have to actually do the problems for this, for the chapter 6 stuff. Now we need to start going through and figuring out the force in each member of the truss. Well, when we're doing the method of joints, we can only pick a place that has at most 2 unknowns. So which ones have 2 unknowns? Okay, so let's look here. Here at C, you have an unknown in this direction, right, and an unknown in this direction. So there's 2 unknowns there. Here at B, we have 1, 2, 3, 4, so that's no good. Here at E, we have 1, 2, 3, so that's no good. At D, we have 1, 2, 3, no good. And at A, we have 1, 2. So it looks like we can start either at A or C. I happen to do A, so let's go with A. So here, let's look at point A. At point A, what do you have? Here's point A. You have a force down here. That force is known. It's given as 2,000 pounds. Okay, and then we're going to have a force here. So you just pick a direction. If you draw it in the wrong direction, you'll get a negative number. Now, in this case, I can kind of figure out which direction it's going to go. How do I do that? Well, this downward force, the only thing that's going to counteract that downward force is going to be this upward force. This is AD, and this is AB. And so I'm going to know AD needs to point up. That's just a simple way to do it. So let's say sum of the forces is in X equals sum of the forces in Y equals 0. Well, where am I going to start with? I'm going to start with Y because in X, AD has an X component and AB has an X component. And that's going to give me two unknowns. But for this problem, the only thing in Y is AD. So if I do sum of my forces in Y, I'm going to get this. I'm going to have 2,000. Oh, that was not what it was expected. Okay, I have 2,000 is equal to AD in Y, right? So let's draw this little picture. What does AD look like? We have this, right? We have a 6, 8, so we can figure out this last one's going to be 10. So therefore, 2,000 is equal to AD, and the Y component is 8/10. So therefore, AD is equal to 2,500. Now, is it in tension or compression? Well, I got a positive number, which just tells me that I drew the arrow in the right direction. Don't get hung up on thinking that positive is one or negative is the other. It just means I drew the arrow in the right direction. Well, which direction did I draw? I draw it, so it's putting a force in that direction, so that's in compression. So AD is 2,500 pounds in compression. And then we can just take our sum of the forces in X equals 0. And what do we have in X? Well, we have our AD in X is equal to our AB. So that's 2,500. Now it's going to be times 6/10 is the x component of it, is equal to AB. And so therefore AB is equal to 1,500. Again, I got a positive sign, which means what? Means it's in tension or compression? No, it just means I drew it in the right direction. And so how did I draw it? I drew it here away from that point, so this is in tension. Okay, so now I know this one, and I know this one. Okay, so now I need to move on. So you'll notice here, looking at point D, now I have 1, 2 unknowns. This one is no longer an unknown, so I can do that. So let's go to point D. So this is all at point, so I'm going to see if I can kind of circle this. This is all from knowing stuff at A. Now let's go on to point D. Okay, and at point D, what do we have? We have, here's point D. We have an AD. So now, and remember, it's the opposite direction. It's coming in like this now. So that's AD. We have a force going off here. Again, you pick a direction. I happen to know it has to go up. Why? Because AD has a down component of it, and DE has 0 Y components. So it has to be up. So this is DB. You don't have to know that. That's fine if you don't do that. And then here, they're both pointing to the right, so I can draw this one to the left because I'm pretty sure it's going to have to go that way to counteract that. And this is DE. Okay, so let's take some of the forces in which direction. Well, again, DB and DE both have X components, whereas DB is the only one that has Y components. So I can go start with Y, make my life a little easier. So the force in Y is equal to 0. So I can have AD in the Y is equal to DB in the Y. Okay, fair enough. So what does that mean? AD is 2,500. 2,500 times the Y component is 8/10 is equal to DB. And what is a Y component? Well, it's the same triangle, so it's going to equal to 8/10. So that obviously just cancels. And so therefore, DB is equal to 2,500. And tension or compression, well, it's pulling away from it, so that is in tension. Okay. Now let's do our sum of the forces in X equals 0. And so you have AD and the X component of the AD, right? In this case, it's going to be plus the DB, the X component of DB, is equal to DE. Okay, so we know what those are. They're 2,500 times 6/10 plus DB, which is 2,500 times 6/10 is equal to DE. So therefore, DE is equal to, I wrote this down, so I'm cheating, 3,000. Okay, and what is DB's in tension or compression? It's positive, which means nothing. It just means the arrow's in the right direction. So therefore, I drew it in towards the force, so that is in compression. Okay, so now I know this one, I just figured out this one, I figured out this one. So where do I want to go? Quite frankly, the first time I did this, I went on to point E. And point E, I have 1, 2 unknowns, so it's good to go, right? But it turns out it's a little bit of a harder problem because they both have X and Y components, so you have to solve 2 equations and 2 unknowns. Not the worst thing in the world. It's doable. You'll get the right answer. But I'm going to be lazy, and I'm going to pick another point. So I'm going to jump all the way over at B. How many unknowns do we have at B? Actually, we could do B right now because we have those, but I'm going to jump all the way over to C because that's what I did in my notes and I don't want to get lost. So all this stuff was from, just kind of highlight this. This is all from point D. This is all from point A. So now let's go to point C. Okay, at point C, what do we have? We have this point right here, right? You have 7,000 coming in this direction. We have an unknown in this direction and an unknown in this direction. Again, you don't have to draw the arrows necessarily right, but I'm pretty sure that arrow is going to come up. This is EC and this is BC. Okay, so I'm going to scroll up a little bit and we're going to do sum of the forces in X, or let's start with Y is equal to 0, right? So EC and Y is equal to 7,000. So that is EC times, all these are the same triangle, so times 8/10 is equal to 7,000 So EC is 8750. Again, tension or compression, it's going into the point, so it's going to be in compression. Okay, now we're going to do sum of the forces in X equals 0. So we have BC is equal to EC in the X direction, which is equal to 8750 times 6/10. So BC gives you 5250, and again, it's in, this one is in tension. Okay, so we just figured out this one now, and this one. So all we have left are, well, is it just BE? I think that seems to be all we have left. So we can pick point E, we can pick point B. Okay, this is all from point C. I picked point E quite arbitrarily. So at point E, what do we have? We have this known thing. We're putting in 10,000 pounds up. We have EC coming in like this. This is EC. We have EB going that direction. We have DE coming in this direction. Okay, well, we know EC, right? That's right here. We know DE, we found that somewhere right there. We know BC, which doesn't come up. So we know ECD. Yeah, that's it. Okay, so in this case, you can do some of your forces in X or some of your forces in Y. Quite frankly, it doesn't matter because there's only one unknown. So let's say sum of the forces in Y is equal to 0. So in this case, we have EB in Y plus 10,000, because this is how I drew it, is equal to EC in Y. Okay, so that's EB times 8/10 plus 10,000 is equal to EC, which is 8750, but in the Y component, which is times 8/10. Okay, so EB is going to give us a nice big negative number, minus 3750. Okay, it's negative, therefore it means what? It means I drew the arrow in the wrong direction. And so this arrow should have been in this direction. Okay, which just means what? If it's in that way, this means it's therefore EB is equal to 3750 in compression. Again, please, please, please don't try to convince yourself that negative is tension and positive is compression. It just means when I drew it, I drew it initially away from the point, which means it would have been in tension, but since it came out with a negative number, it means I drew it in the wrong direction, which means it's in compression. Okay, and I think we have I think we've sorted them all out. So it's a bit of an extended process to go through every single step. It's not hard. The key is, there's a couple keys, right, that you can only solve for two unknowns, because we don't get to use the sum of the moments, right? In general, when you're doing two-dimensional problems, you can usually do three unknowns because you get to do the sum of the moments, but here we're not dealing with moments, so you just have to do sum of forces in X and Y, so you can always only solve for two unknowns. There's some that are easier than the others. Again, remember, I went from A to D and then to C. When I did it in my notes, I actually did E next, and I got the right answer, but it's a bit of work because you end up with two equations and two unknowns. It's just a little bit harder to do. Whereas if you can make steps to only have, say, one component in a X or a Y, it just makes life a little bit easier. But there you go.